9.2 L'Hopital's rule. We have an indeterminate form which is 0 over 0. If functions f of x and g of x are both 0 at x equals a, then the limit as x approaches a will be 0 over 0. And the limit cannot be found by substituting x equals a. The substitution produces 0 over 0, a meaningless expression known as an indeterminate form. And throughout the chapter we'll be talking about lots of different indeterminate forms, but the first one that we discuss is 0 over 0. L'Hopital's rule, first form. Suppose that f of a equals g of a equals 0. So in other words, if you plug a in to either one of these functions, the result is 0. That f prime of a and g prime of a exists, so the derivatives exist. And that the derivative of g at a is not equal to 0, because then we would still have 0 in the denominator. Then the limit as x approaches a of f of x over g of x is equal to, just take the derivative of the top, the derivative of the bottom, and plug a into that. Let's look at an example. We have an indeterminate form of 0 over 0 on this one. Estimate the limit graphically, and then use L'Hopital's rule to find the limit. Let's not worry about the graphic part. Let's just do this by hand. If we plug 0 into the top and the bottom, we have the square root of 1 plus 0, and then minus 1, over 0. And that's the square root of 1 minus 1 over 0. Square root of 1 is 1. 1 minus 1 is 0. We have 0 over 0. Now that does not mean the limit does not exist because we have 0 in the denominator. It just means it may not exist, but we're not sure yet. We can take the derivative of the top and the bottom. So we can do L'Hopital's rule. And anytime we do L'Hopital's rule, we write that to say, hey, we are actually performing this operation. We have the limit as x approaches 0 of 1 over 2 square root of 1 plus x. And then the derivative of this negative 1 will be 0, and then the derivative of the bottom will be 1. Now we can plug 0 in without getting 0 in the denominator. We have 1 over 2 square root of 1, which is equal to 1/2. Theorem 5, L'Hopital's rule, the stronger form. Suppose that f of a equals g of a, and they both equal 0, that f and g are differentiable on an open interval I containing a, and that g prime of x does not equal 0 on I if x does not equal a. Then, the limit as x approaches a of f of x over g of x equals the limit as x approaches a of f prime of x over g prime of x, if the latter limit exists. All that means is you can do this over and over again. Let's plug 0 into this function. We get 1 plus 0 minus 1 minus 0 over 2. And then we have over 0 squared. Well, this piece right here is going to be 1. 1 minus 1 is 0. This part is 0. We do end up with 0 over 0. So let's do L'Hopital's rule. We'll signify we've actually done the rule. We have limit as x approaches 0 of 1/2 1 plus x to the negative 1/2. That's the derivative of square root of 1 plus x. Derivative of 1 is 0. And the derivative of negative x over 2 is negative 1/2. And then we have over 2x. If we plug 0 into this, we get 1/2 times, we have 1 to the negative 1/2 when we plug 0 in. That's just 1. So we have 1 and then minus 1/2 over, 0. 2 times 0. That's equal to 0 over 0. We still have an indeterminate form, which means the stronger case says we can do L'Hopital's rule again. We have the limit as x approaches 0 of, now we have negative 1/4, 1 plus x to the negative 3/2. The derivative of negative 1/2 is 0, and then in the denominator we have 2. That's equal to negative 1 over 8 times 1 plus x to the 3/2. Now when we plug 0 into this, I guess we still have limit as x approaches 0 here. When we plug 0 in here, we get this piece becomes 1. The answer is negative 1/8. So the original limit of this function as x approaches 0 is also negative 1/8. Evaluate the following limits using L'Hopital's rule. We have the limit as x approaches 0 from the right of sine of x over x squared. If we plug 0 into this, we get sine of 0 over 0 squared, which is 0 over 0. That's an indeterminate form. We can do L'Hopital's rule, and we have limit as x approaches 0 from the right of cosine of x over 2x. Now that's equal to the cosine of 0 over 2 times 0. Well, that's equal to 1 over 0, but we have to remember that we are going on the right side of 0, which means positive values. 1 over 0 is equal to infinity, because remember, we're approaching 0. So that's like taking 1 divided by 0.0000000, keep on going 1. You'd go on forever. Well, that's going to be an extremely large value, but it's going to be extremely positive. So the answer to this one, 1 over 0, is actually infinity. Let's look at limit as x approaches 0 from the left. This is also sine of 0 over 0, which is 0 over 0. We have the limit as x approaches 0 from the left, we're doing L'Hopital's here, of cosine of x over 2x. Now this is not 0 over 0 because we have cosine of 0 over 0, which is 1 over 0, but now we're approaching 0 from the left-hand side. So that's like taking 1 divided by negative 0.0000. Keep on going, very, very small numbers because we're approaching 0, but now we're on the left side. So the answer is negative infinity.